Hello and welcome to this Gap Year conference. I'm Dr. Sujoy, the Chief Medical Information Officer for Apollo Hospitals. We all know that artificial intelligence and machine learning and deep learning in particular is empowering the use of labeled clinical data, big in terms of volume, velocity, scalability, with significantly enhanced computing power and cloud storage. In clinical practice and public health, this is making initial steps to have an impact at the four fundamental levels. For patients, by enabling them with better decisions for access to process their own data, federated and secured, meaningfully used to promote health. For clinicians, predominantly via supported, accurate interpretation of patient data, including electronic health records and imaging. For health systems, by improving throughput, enhancing patient safety, and the potential for reducing healthcare cost. And ultimately for the technology providers, constructing digital health platforms and creating positive network effects where patients, providers, payers, and physicians can derive intense clinical value. Today, we being three eminent chairpersons, it is my privilege to invite Dr. Palu Malawala, Dr. Naveen Dang, and Dr. Giridhar Gyani, three distinguished speakers, Ms. Arunima Sarkar, Dr. Venkatraman Sundareswaran, and Dr. Srinivas Raju, to reflect back on this subject, which I would put it as future of medicine. For the audience, I would send say that you put your questions in the chat box and email ID with name and email ID, and we will reply it as soon as we can, probably within 1 week of after this conference is over. At this time, I would like to invite and introduce Chairperson Dr. Palu Malawala and invite her to introduce our first speaker, Ms. Arunima Sarkar. Dr. Malawala holds a postgraduate degree in ophthalmology from Ahmedabad, India, and is current president of Australian Indian Medical Graduate Association. Dr. Malawala is the founder director of Rosal Surgery, and she set up 25 years ago in the city of Parramatta, Sydney. Over to you, Dr. Malawala.
Thank you, Dr. Sujoy Kaur, for your kind introduction. I would like to take this opportunity also to thank Gapio for giving me the opportunity of chairing this very important topic of artificial intelligence and machine learning. I would like to introduce Mrs. Arunima Sarkar. Mrs. Arunima Sarkar is currently the Artificial Intelligence Lead at the Center for Fourth Industrial Revolution World Economic Forum. She leads the co-design of governance, protocol, and technology policy frameworks for artificial intelligence for maximum benefit to the society and mitigating any unwarranted outcomes, biases, and risks. Mrs. Sarkar has more than 20 years of experience in research, corporate growth, strategy initiatives, technology policy, with special focus on data, analytics, and artificial intelligence. Mrs. Sarkar also leads the Global Applied Intelligence Research for Accenture and has also worked in technology consulting and research roles in organizations like Gartner. Mrs. Sarkar has been leading several initiatives with multi-stakeholder communities around AI and ethics and operationalizing artificial intelligence ethics guidelines across several sectors and applications. We are very lucky to have Mrs. Sarkar here with us, and I really am looking forward to hearing you talk today, and I request you to begin your talk. Thank you.
Hi, this is Arunima Sarkar. I am the AI lead at the Center for the Fourth Industrial Revolution World Economic Forum, and today I'll be talking to you about AI ethics and healthcare. So we have all seen that the potential impact that AI can bring to healthcare is increasingly being recognized across the world by healthcare organizations, academics, and various professional organizations. And we have seen that AI holds great promise in terms of beneficial, accurate, and effective preventive and curative interventions. But at the same time, there is also an awareness of the potential risks and harms that can be caused by the unregulated development of artificial intelligence in various use cases and applications. A series of guiding principles are today being developed around the world to foster the trustworthy development and application of AI systems. And these guidelines can actually support the developers, the hospital systems, the regulators, and governing authorities while making decisions about the use of AI in a responsible manner. And we see that there is an urgency for shared globalized efforts to safeguard against the potential harms of AI technologies in healthcare. So as we try to scale the use of AI in global healthcare, there are certain gaps and challenges that come up and which we need to overcome. These are a few that I've listed today. There are some concerns around health system integration and capacity, the data availability and quality challenges, limited evidence base for impact of AI tools, regulatory and policy issues, and finally, the concerns that arise around data privacy and AI ethics. So today I'll broadly be speaking about the data privacy and AI ethics. But before I get into the details of this specific area of governance gap that we see in the use of AI, I'll touch briefly upon the other four challenges as well. In terms of data availability and quality, so significant challenge to accelerating the use of AI-enabled tools relates to the quality and quantity of available data. And due to the general lack of digitalization in several developing markets, that could be a significant challenge. So a strong digital healthcare infrastructure is needed so that we can provide the data that is required for AI tools, and which is a challenge in many countries. And on top of that, low electronic health records adoption rates could also hamper the ability to actually aggregate historic and real time patient data. The other challenge that I've mentioned here is around the need to integrate with local health systems, which means that many AI tool providers have to offer highly customized AI tools for the local or regional context. And the related issue is that weaker health systems in developing countries would mean limited means of actually collecting or storing digital health data. And this could again inhibit the use of AI tools. A third challenge that I've listed here is the limited evidence base for impact of AI tools. So we need to build definitions of acceptable performance standards, accuracy rates, and patient health outcomes against which we can measure AI. And further, the perspectives, they vary widely in terms of what standards should AI tools adhere to in order to be used across countries and for patients and doctors to be able to trust them. At a more granular level, there is also ongoing debate about the variability in the accuracy standards across different types of AI tools. The fourth point that I have is around the regulatory and policy issues. And there are certain enablers around this bucket of concerns which could actually help in scaling the use of AI in global health. To list a few of them, so encouraging an open data system that ensures that data meets the standards which are set in terms of interoperability, privacy, and safety is available. Encouraging AI research and development, which means if you enable medical colleges to develop centers devoted to research on AI and facilitate the exchange of knowledge between academic centers across countries could be hugely beneficial. Designing standards and appropriate certification systems for health systems driven by AI is another policy lever which could enable the scaling of AI in healthcare. There are several regulatory and data sandboxes also which have been promoted as tools for enabling innovation while protecting privacy, security, etc. And finally, a very comprehensive and harmonized implementation of electronic health records policy is key in enabling the various AI startups who are developing health solutions to get access to accurate and usable data sets. I would now get into the details of the key topic here that I'm talking about today. That's the data privacy and AI ethics concerns. So there are several ethical considerations which come up when related to the use of artificial intelligence in healthcare. I've tried to summarize and a few key points that come up as we try and implement, design, develop, and deploy AI solutions in healthcare. One key concern is around consent. So informed consent has been seen as the key ethical requirement for medical treatment and research. And this is to be supported by requirements for professional confidentiality and personal privacy. So the questions which arise are, whose data is it really? Does it belong to the patient? Does it belong to the system which is collecting and aggregating the data? Or does it belong to the developer? Patients do not in most cases know that the data about them and their disease is being collected and used. And even when they are told, very few of them actually opt out. Coming to the data integrity question, so the accuracy and completeness of data sets which are used to power AI solutions are key for accurate and unbiased results. And many of the issues regarding privacy and information governance, they require very careful and detailed explanation to the patients. So is this practical and is this affordable is one of the key questions when you look at these data integrity questions. Patient safety. So what is the threshold for patient safety? And how do we compare this to the standards to which a human clinician is actually held? Who will be responsible if harm is caused by AI mistakes? Is it going to be the computer programmer, the technology company, the regulator, or the clinician? And should a doctor have an automatic right to overrule a machine's diagnosis or decision? These are again some questions which come top of the mind when you talk about patient safety. Coming to the topic of bias, inequality, and unfairness. So clinicians will need to be very confident that the decision support tools are valid for the patients in front of them and not just the specific group that made up the training data. So how can we stop algorithms from actually reinforcing their own behavior when they make mistakes? And if training data is only obtained by those who specifically volunteer and consent for their data to be used, it is possible that the algorithms are learning from unrepresentative data sets, which can then lead to the issues of bias and unfairness. Coming to algorithmic accountability, it is necessary to ensure that an algorithm is learning from its mistakes and successes. It should be incorporating new medical findings, demographic changes, and technological developments, and it should be conforming to the prevalent medical and healthcare standards. So liability in case of error in diagnosis, in case of a malfunction of the technology or the use of some inaccurate or inappropriate data sets, the question arises that where does the liability fall upon? Is it upon the doctor or the software developer? The questions of transparency. So can a doctor be expected to act on the decisions which is made by a black box AI algorithm? So in deep neural networks, the reasons and processes underlying the decisions made by an AI may be very difficult to establish even for skilled developers. So do doctors really need to explain that to patients when they actually use AI tools in their treatments? And finally, a cornerstone and a key area of concern is how do we build the public acceptance and trust of this technology, specifically in a sensitive field as healthcare? So how transparent should AI providers be about how the data is being used? Are there any nationally agreed standards for quality? If there are, then should there be? And if we do have such standards, then who should be responsible for building such standards? Should and one key question is, should patients be given a choice about whether a doctor or an algorithm makes their diagnosis? So these are just a summary of few questions under each of these buckets that I thought of sharing with you. The list is not exhaustive. There are several such ethical considerations which come up when we try and talk about deploying AI in healthcare applications. So to deal with such AI ethical issues in healthcare, the World Economic Forum is currently running a project. It's called the Chatbots Reset Project. It's about building a governance framework for the responsible use of conversational AI in healthcare. So what we have done in this project is we have got together under the same community, the project community, chatbot developers, chatbot platforms, medical community, civil society, academia, and healthcare regulators. And this entire community together has co-designed this framework for the responsible use of conversational AI in healthcare. The broad objective is to try and scale the use of this technology in a responsible way so that we can maximize the beneficial uses while minimizing the negative consequences. We are happy to have just completed the framework development, and we have launched this framework this month, earlier last week. And for any of you who would like to join this initiative of the World Economic Forum to try and test out this governance framework, you're welcome to join us. And this is the contact ID where you can contact us and be a part of this initiative at the World Economic Forum. Thank you.
Thank you, Chairperson Dr. Palu Malawala, for introducing the speaker. And thanks, Ms. Arunima Sarkar, for giving such an excellent talk. Now, I would like to introduce Chairperson Dr. Navin Dang and invite him to introduce Speaker Mr. Venkatraman Sundareswaran. Mr. Dang is an alumni of Delhi University, PGI, Chandigarh, and AIIMS, all the three reputed institutions, and is a recipient of Dr. B.C. Roy National Award for his contributions in the socio-medical field. Dr. Dang is the director of Dang's Lab, New Delhi, which was started in 1985. He's also known for pioneering quality in the field of diagnostics in India. Dr. Dang is a governing council member of Initiative for Providing Affordable and Quality Tests for Tuberculosis, Association of Practicing Pathologists, and a member of expert group of TB prevention and control on the National Forum of Tuberculosis. Over to you, Dr. Dang.
Good morning, everybody. Thank you, Dr. Sujoy Kar, for an extremely kind introduction. I'm privileged to be a part of this program. Thank you, Gapio, for giving me the privilege again of being a part of this program and being here with all of you, and also giving me the chance to introduce Dr. Venkatraman Sundareswaran. Dr. Venkatraman Sundareswaran is a fellow from Mitsubishi Chemical Holdings Corporation at the World Economic Forum, working on responsible use of chatbots in healthcare. Dr. Sundar is a seasoned technologist with research development, profit and loss executive leadership experience. Dr. Sundar has a master's degree in natural language understanding from the Indian Institute of Science and a PhD in artificial intelligence from New York University. Now I would request Dr. Venkatraman Sundareswaran to please come and deliver his talk. Thank you. Thank you very much indeed.
Thank you, Dr. Dang, for your kind introduction, and Dr. Sujoy Kar for the opportunity to present here. Greetings, everyone. In this presentation, I would like to share some work I have been doing at the World Economic Forum. As you may know, the World Economic Forum is headquartered in Switzerland. The forum launched a center in San Francisco nearly 4 years ago to look at responsible use of technology. My name is Sundar, and I am a fellow from Mitsubishi Chemical Holdings Corporation in the Artificial Intelligence and Machine Learning team at the World Economic Forum. The topic of my presentation is chatbots and their use in healthcare. Chatbots, as you may know, is a form of artificial intelligence that allows users to interact using natural language, using text or voice. You'll find them on websites for customer support, on apps, and on messaging platforms like WhatsApp and Facebook. Chatbots are being deployed in healthcare, including in mental health applications. The purpose of this project, which is titled Chatbots Reset, is to explore issues that will come up in the type of deployment in healthcare and provide a framework to the various stakeholders involved. As I mentioned in the last chart, chatbots are starting to be used in healthcare. When you respond to patients using this automated technology, there are many benefits. It can be accessed 24 hours a day, any day of the week. One chatbot can service thousands of patients, so it can be a low-cost tool. Chatbots can be created and deployed quickly. For example, some of the COVID-19 chatbots notably the MyGov Corona Help Desk deployed on WhatsApp by the government of India, which was developed and deployed to millions of people in a matter of days. They can provide consistent, curated information. They can be repurposed for other healthcare applications, and they can generate a lot of data, which is important to train future applications. To see why we should pay attention to this technology, let's see how it is trending. The pandemic is acting as an accelerator for chatbots. The WHO and CDC have deployed chatbots, and there are over 1,000 chatbots deployed using the Microsoft Bot platform alone. People who are using these chatbots are getting used to having their questions answered in this manner. And there are cost and efficiency benefits compared to having human operators answer the questions. Beyond the pandemic, there are several reasons why we believe chatbot adoption will be sustained. AI is built into the chatbots that are used for COVID-19, and it is ready to take on many more use cases. Most chatbots are HIPAA compliant, and some are even FDA approved as medical devices. Integration with hospital IT systems and even national healthcare systems is happening. For example, the NHS in the UK has worked with the chatbot provider Babylon Health to make the chatbot available to the NHS customers as GP in the pocket. These trends point to acceleration of the adoption of chatbots in healthcare, which can lead to many benefits I spoke about in the previous chart, but can also create many issues that could lead to negative impacts. This word cloud in this chart depicts some of the potential issues. Bias, fairness, privacy, transparency, legality, and inclusiveness are some of them. But you can see there are many challenges that will be faced by the people who are using this system, and we need to make sure that these are addressed. To address these potential negative impacts, we at the World Economic Forum decided to develop a governance framework. Here we see the timeline during the last year. Starting with discussions with a broad cross-section of experts in January, we convened a panel discussion of global players in March to look at how chatbots are used for COVID-19 and how they might be used beyond the pandemic. This discussion convinced us that a framework is essential. In May, we convened a group of global experts to dig deeper into the use of chatbots in healthcare. This was in a workshop that laid the foundation for the framework. Over the next several months, we worked on the framework with an incredible team of international experts, which included technologists, physicians, academics, small and large private sector enterprises, and governments. And we published the framework in December in the WEF website. This chart shows some of the members of the project community who actively participated in the creation of the framework. As you can see, it included large companies like Microsoft, Tech Mahindra, Apollo Hospitals, which is Dr. Sujai Kar, and Reliance. There are several startups like Dialog, which is from Germany, Omnibot, also from Germany, Orbita from the US, Your.MD from the UK, and Ada Health from Germany. And you can see that there are academic participants as well. Excuse me, I made a mistake in this chart. Can we go back?
Yes, doctor, you can continue from the slide, from the beginning of the slide.
Okay, thank you. This chart shows some of the members of the project community who actively participated in the creation of the framework. As you can see, it included large companies like Microsoft, Tech Mahindra, Apollo Hospitals, which was represented by Dr. Sujai Kar, and Reliance, startups like Dialog from Canada, Omnibot from Germany, Orbita from the US, Your.MD from the UK, and Ada Health from Germany. Academic participants included Dr. Murali Doraiswamy, practicing physician and technology innovator at Duke University, Carnegie Mellon, University of West England, and University of South Carolina. Government organizations, including the National Health Authority of India, Public Health Foundation of India, and the Singapore Data Protection Commission. Another physician who contributed is Dr. Nupur Kohli from the Netherlands, who is a World Economic Forum Global Shaper. This chart gives a glimpse at the framework. What we did was we took principles from AI ethics and healthcare ethics and selected about 10 of them that directly apply to the use of chatbots in healthcare. These are shown in the circle to the right. We not only picked the principles, but we also interpreted them in the context of the use of chatbots in healthcare. But we didn't stop there. For each principle, we developed a list of actions that can be taken by technology developers, healthcare providers, physicians such as yourselves, and government regulators to ensure responsible use through implementation of these principles through the actions. We are now working with several World Economic Forum partners to validate the framework and provide feedback to us by applying these principles and actions to their projects. Based on the feedbacks we get, we will update the framework and reshare, which is available to everyone. And in fact, the initial version of the framework is available for download from the World Economic Forum website if you would like to learn more about the details of the framework. Thank you very much for your attention. And here is my contact information. If you have questions or would like to discuss or provide contacts to me. Thank you very much.
Thank you, Chairperson Dr. Naveen Dang, for introducing the speaker, and thanks, Mr. Sundar, for an excellent work and also the excellent talk. Now it is my privilege to introduce next chairperson, Dr. Girdhar Gyani, and invite him to introduce our speaker, Dr. Srinivas Raju. Dr. Girdhar Gyani, who is known to all of us, is the Director General of Association of Healthcare Providers of India, which is working for building capacity in Indian healthcare system and with the advocacy with the Government of India. Prior to this, Dr. Gyani, as you would know all, was the Secretary General of Quality Council of India and has been instrumental in bringing in the concepts of healthcare quality in India through NABH, with global recognition, bringing patient safety, healthcare quality in forefront of Indian healthcare system. Dr. Gyani, over to you.
I thank Dr. Sujoy for a kind introduction. I also thank GAPIO for giving me the opportunity to chair the talk during the current session on artificial intelligence and machine learning. Dr. Srinivas Raju is the CEO and Medical Director, Apollo Radiology International. Dr. Raju is radiologist with subspecialty interest in abdominal imaging. Dr. Raju has done his postgraduate training at NIMS Hyderabad, India, and at Leeds Radiology Training Scheme in UK. After working for nearly 10 years in UK as a consultant radiologist in the NHS, Dr. Raju returned to India in the year 2012. Dr. Raju has substantial experience in clinical leadership, having held senior positions of responsibility both in UK and in India. Dr. Raju is passionate about finding ways to improve access to high-quality diagnostic radiology by healthcare providers in rural and remote areas in India and by using the power of technology. To this end, Dr. Raju has been leading several efforts by ARI in the field of teleradiology and artificial intelligence. May I now request Dr. Srinivas Raju to give his talk.
Thank you, Dr. Giridhar and Dr. Sujoy, and thank you, Gapio, for this opportunity. My topic today is artificial intelligence in imaging, an emerging perspective. I'm going to be spending the next 8 minutes or so taking you through the current status of AI in imaging in globally and specifically focusing on India. As most of you know, radiology is now at the heart of patient journey for most diseases. Over the last few decades, it has greatly increased prominence and recognition. It now plays an important role in helping most clinical specialties. And we've seen fascinating advances like cardiac imaging and virtual endoscopy in the last couple of decades. Radiology is highly sought after by potential trainees, and it has now reached globally due to teleradiology, which took away the borders between radiology services. However, despite its rapid growth, radiology has been struggling predominantly due to lack of enough radiologists. There is also a limitation in terms of duration of training because there is rapid growth in the specialty and new modalities and advances. Countries like India, which traditionally train radiologists for 3 years, are struggling to include the entire curriculum into those 3 years. There are worldwide shortages in the number of radiologists. There has been a rapid increase in the number of scans performed as well as the indications for these scans. There is also a vast increase in the number of images per each study on the modern machines. And because there is now a low threshold for requesting radiology, there are too many normal examinations. And all these have led to overwhelmed, tired, exhausted, and error-prone radiologists who end up spending most of their time detecting lesions and less time in clinical interpretation. In this era of minimal error and personalized and precision medicine, radiologists, like other healthcare professionals, need help to deliver this. AI is an extremely powerful tool that can enhance the practice of medicine in multiple ways, and this particularly applies in radiology. This is a graph by Gartner, which was published back in August 2018, which shows the status of AI at that point in time. At that time, the AI was at the peak of inflated expectations. There was a lot of hype around it. I think we are now at the beginning of the downward slope of that inflation in terms of the expectations from AI. I think we will see that going on for the next couple of years, during which time there will slowly be implementation of more practical and realistic applications of AI in day-to-day clinical practice. As you can see, as a plateau of productivity that I think will happen in the next 2 to 3 years. The first benefit that we will see from AI is in the form of AI-assisted workflow efficiencies. Because these do not require regulatory approvals, I think these will be implemented quite fast. This includes things like triaging of patients, prioritization of worklists, etc., which will improve radiologists' efficiency and effectiveness, although these are not necessarily clinical applications. This will be followed by a wave of AI-assisted diagnostic tools. There is a large number of players that are currently working on a vast variety of use cases. Some of them are already becoming established. These include brain bleed detection, breast cancer detection on mammography, and detection of fractures. There is also increasing interest in application of AI in matters that are of population health interest, like detection of calcium scoring on normal, non-gated, non-contrast chest CT scans, as well as diagnosing TB from chest X-rays. As you all know, there is a global disparity in terms of access to radiology. According to World Health Organization, approximately 2/3 of the world's population lacks adequate access to medical imaging. There is expected to be a steep increase in mortality related to NCDs across the developing countries over the next decade or two, and lack of access to radiology can grossly undermine the public health initiatives that we may undertake to tackle this threat. The fight against other diseases like TB is also being impaired by lack of adequate access to radiology. If you look at the developing countries, and especially India, there is a gross inequality in the healthcare services in the urban and rural areas. About 67% of the Indian population lives in rural areas, whereas nearly 90% of the medical imaging facilities are in cities and towns. This has caused an acute shortage of radiologists in rural areas, resulting in severe delays in diagnosis of acute or life-threatening conditions, and also other pathologies like cancer. The result of this is a large amount of preventable mortality and morbidity. The radiology workforce situation in India is not good. We have around 1 radiologist per 100,000 population, compared to 1 in 10,000 for the US. Annually, there are about 747 postgraduate training vacancies, and the duration of training is 3 years compared to 4 or 5 or 6 years in the developed countries. And there are a very small number of subspecialty training programs. And this scenario is unlikely to change in the near future, because the training numbers cannot be increased due to a short supply of suitable departments. And the training duration is already short, so we cannot really further shorten that. So this leaves us with opportunities or a search for leapfrogging through disruptive technologies and innovations. These include teleradiology, AI, or a combination of both. Teleradiology has been a reasonably effective solution for nearly a decade. It for the first time gave access to reporting for remote locations. Reporting by well-qualified radiologists has been made possible. Several state governments across India have granted mass outsourcing contracts of their rural radiography reporting to private teleradiology companies. However, teleradiology does not take away the fundamental problem of not having enough radiologists. Also, those radiologists who do teleradiology are usually already in very busy day jobs and do this in the evenings or nights, which means that they are overburdened and are prone to high rates of error. We believe that AI can help bridge the gap. It can augment both on-site and remote radiologists to improve access, efficiency, and turnaround. And in the context of an absent radiologist or few radiologists, as is the case in towns and villages in India, the value addition of AI can be much more substantial and less controversial when compared with the other contexts that you might see in the developed countries. Thank you very much.
Thank you, Dr. Gyani, for introducing the speaker, and thanks, Dr. Raju, for the excellent presentation, as always. Now, I would like to present a work that we have been doing at Apollo Hospitals for the past 7-8 months, where we were looking at the current pandemic. We were looking at, patients who were coming to our hospitals and getting admitted, and trying to predict an outcome of these COVID patients, looking at their parameters, clinical parameters, and lab parameters at the time of admission. So what you can see here now in the slide is that we actually collected about 1,435 retrospective patient records with COVID from 6 hospitals in Apollo Group from April to July 2020, where we looked at about more than 100 different clinical and lab parameters at the time of admission. And we sort of, had to drop out for about 42 records because there were a couple of missing values in each one of them. And we were not eager to use what we call in machine learning system imputations. In 1,393 discharge records, we had about 119 expired patients with a rate of about close to 8.54% and about close to 1,274 survivors. And then at this time, we did the propensity matching, did the other statistical activities like odds ratio, relative risk, p-values, z-score, and then moved on to build 3 or 4 different models with 23 parameters, trying different machine learning activities like, logistic regression, CART, random forest, and then ended up with gradient boosting model. Whatever the results we got from the gradient boosting model, at the time, we actually generated an API. And I'll be showing you in my slides how this API looks, where we are putting in the clinical and the lab parameters, and we're getting the risk score generated for the patients. At that point of time, it was very important for us to go to the ethics committees of these hospitals, take their approval, and get their validation done. Now, prospectively speaking, starting from August to October 2020, we collected about 973 prospective patients and used them in the validation cohort and did the complete study. So if you look at the next slide, these were all the different parameters that we had. This is a very busy slide, but we sort of looked at all the 23 parameters on the left, and then looked at it from the aspects of recovered and expired patients for both development and validation perspective, and looked at also the odds ratio, z statistics, and p-value to determine which were the important components that we were getting at that point of time. And if you see the next slide, you would see how the model was performing. For the gradient boosting model, for the development cohort, we had a sensitivity of close to about 80% and specificity of 98% with an accuracy of around 0.97, and then good precision and recall and F1 score. This was the model performance in the cohort of 1393. When we looked at in the validation cohort, we had an AUC-ROC of close to 0.78, and the precision and the recall score where effective accuracy was around 0.93. Now, if you look at the other statistics like positive likelihood ratio, it was around 15, and positive predictive value was around 60%, whereas the negative predictive value was around close to 97% for the model that we had prepared. The other exciting thing is this, that when we compared other models, we found out that the AUC-ROC score for gradient boosting was much better than what we see normally for random forest, logistic regression, or even for that CART model. And accuracy and the sensitivity were also very, very high from that perspective. These are some of the interpretation of how we looked at. These are the violin graphs of different parameters. As you can see, this is the one where we are looking at oxygen saturation at the time of admission. And these are people who expired, whom we are putting it as 1, and 0 are the people who survived. And as you can see, the differences between the two violin graphs, and we can see many of their patients who expired had a baseline SpO2 or saturation below 90% at that time. Similarly, the respiratory rate was higher than 25 for many of these patients. And when we start looking at different lab parameters, lactate was higher for patients who expired. We found that the CRP was one of the strongest marker where we are looking at very high rates of CRP for patients who succumbed. Also, from a lymphocyte perspective, we saw that the lymphocytes were much less than 12% in this group of patients that we were looking at. We also look at very interesting figure around INR, where there were subtle differences, not much of differences with the coagulation factors that we were looking at. Of these 23 factors, as I said, we looked at all the, as you can see, some of the clinical factors, some of the lab parameters, the basic CBCs, and of course, then the pro-inflammatory markers and all of that, coagulation factors, all of these were taken into. This is what we are looking at from, study through an hazard model, where we are looking at, the effect of these particular features in 7 days and 28 days. And we find that age, gender, fever, cough, respiratory distress, and all of these comorbidity like diabetes, hypertension, respiratory rate, SpO2 were, pretty high. The hazard ratios were pretty high for that. Highest was been in terms of CRP, in terms of lymphocyte percentage, the respiratory rate, and SpO2, but both for the development cohort and for the validation cohort. And this is something which is unique, and I haven't seen this much in literature as well. We are able to now map the KM plots for different conditions where we are looking at, comorbidity, as you can see for the development cohort and the validation cohort, where we're looking at heart disease. Somehow it looks like they have been figured out over a course of time, but they would remain same for diabetes and hypertension. As we have been speaking, respiratory distress, respiratory rate, and SpO2 are one of the bigger markers at the time of admissions for overall prognosis of these patients. And finally, when we look at the lab parameters, we look at ferritin, we look at INR, we look at LDH, lymphocytes, and red cell distribution widths in this study to see how they are individually affecting each one of the probable outcome for these patients. Finally, I want to just show you the API that we had generated, where it is available online, where people can use it, where we have the demographics given in, including the consent of the patient. And then we put in the clinical history, comorbidities, patient vital signs, then of course the lab results and all of that. And at the end, we are providing the mortality risk score at the time of admission, the risk categorization, where we are saying 0 to 15% as low risk, 16 to 30% as moderate risk, and more than 30% as high risk. We're also giving the probability of mortality in 1 week, and just to reflect, how this patient would fare as in when we go in. One of the basic feature of this particular model is that it doesn't look at one of these two factors. It looks at the combination of factors to give out, using machine learning, the interplay of different factors to give you a overall mortality risk score or probability of mortality in 1 week. This is a research in motion and is on the way to its publication, but I thought it would be important for us to share this and the AI/ML work on COVID that we have been able to do. Thank you very much for going through the slides, and I hope this will be useful. It is my deepest privilege to actually thank all the speakers and chairpersons for a wonderful session. I would like to say that, the way Arunima reflected on potential impact of AI in healthcare risks and harm, guiding principles and shared globalized efforts are definitely very, very futuristic. But also she reflected on the important aspects around integrity, safety, eliminating bias, and of course the algorithmic accountability, which are key to adoption and also implementation of AI in healthcare. I would like to immensely thank Mr. Sundar in providing us with the work on chatbot reset. I wanted to show how COVID accelerated the thought process in bringing useful chatbots in healthcare and how effective they have been in the past 1 year in triaging patients or giving them correct information at correct times world over. And to put that into perspective, bringing in this framework and converting them in futuristically as guidelines or standards are going to be very interesting work. I feel privileged to be a part of that work, Mr. Sundar, and excellent presentation and excellent work. Lastly, we all were witness to the exceptional presentation from Dr. Raju, and every time I hear him, it gives me a lot of fascination how he covers the aspects of AI in radiology. And one of the important areas that he actually looked at was this, where radiologists cannot reach, where there are unmet needs. Then, of course, the process improvements, better detection of cancers, auto-segmentation and delineation of fractures, bleeds. These are all futures of radiology, and we are so thankful that Dr. Raju is always there to guide us into that. With this, I would like to thank all the chairpersons and speakers again, and all the participants. We'll be back answering all your questions soon. Whenever you feel like, send us those queries, and we will be answering them soon. Have a wonderful time ahead in 2021. Thank you all.